Bismillahirrahmanirrahim. Let us look at example 2. Let us discuss this question. Alright, so we see an integral of radical there. And before we are to begin, compared to the guideline given to us, this is the form of a square plus x square. Do consider to use the trigo substitution. Change the x as a tangent theta. I'm going to redo this, okay, so that we can see the step-by-step work. Let me write this question back. So this question, okay, this is not a simple u substitution, okay, right? So you cannot just say u to be the tangent. This is wrong. Okay, we are actually using trigo substitution. We are supposed to replace these 2x in the form of a trigo. Alright, so that's the difference there between the u substitution method and trigo substitution method. Okay, so and how do we recognize that we are supposed to change into tangent theta? So we look into the guideline that we had earlier. If we have a format of a square plus x square, so the appropriate x there or the variable there is tangent. Okay, and then we are supposed to substitute everything in terms of a trigo. So we do the derivative. For the derivative of the tangent, you look into your formula list. It is secant square. And we need to replace the x, which is this half secant square d theta over there. Alright, and over there. So there's a mark there given for that step. Setting the appropriate trigo substitution. And then integrate. Okay, until you substitute. But yet here we are left with the radical of 1 plus tangent square. So to ease this, you have to use identity. Okay, look into your formula list. The Pythagorean identity, 1 plus tangent square theta is secant square theta. Why so? Because we would like to eliminate the radical there. So secant square root is secant. So there's a mark there for you to change as the identity. And then simplify. And then this is secant cube. I did not put down the border. Okay, why? Because this is the boundary for x. When we change into boundary of theta, we need to change the boundary in terms of theta. But first, let us solve this integral of a secant power odd number. So for that, we need to refer back to our previous work. Refer back to your workbook, page 243. So this is a summary of work that we have done and discussed earlier, okay, on page 243. Okay, so if we have a guideline secant power odd number, we are to use, in this case, this identity, but it does not really work. Okay, so in this case, you cannot use this guideline, but last time we used IBP, integration by part, to solve it. Right, so refer back to your previous work. And let's put the answer, and we've got this for the answer. If I put up in front the half, so we are left with secant theta, tangent theta, plus ln secant theta, plus tangent theta. Let's put the answer for this part. Okay, so that's the answer for this part. Let's put this. So I got this from our previous work, which carries 7 marks, isn't it? 7 marks altogether. Let's get the answer. Here we have 7 marks for the long working using IBP, and we get this. So hence we got this for the answer. Okay, for the indefinite integral. Alright, but yet we are given as definite. Let's change the boundary of this x in terms of theta. But first, what is the relationship between x and theta? So let me quote back the x that we have substituted just now. X is half tangent theta. Okay, so we need to replace and get the theta. So another way to say tangent theta is 2x and the angle theta is our inverse tangent to x. Okay, right. So for the upper boundary now, upper boundary when x equivalent to half, right? So theta would be the inverse tangent of 2 times half, like that, or another word to say inverse tangent 1. Okay, what is the angle? Tangent theta is 1, so theta you can just plug it in your calculator, or you know last time, okay, from our previous work, it is 45-degree angle. Please read it in terms of the real number value, in terms of a radian. Okay, it's pi on 4. That will be for the upper boundary. Next, for the lower boundary, when x is 0, okay, so, and theta, you have to change it, okay, because you cannot get back. For example, what if I would like to replace it back in terms of the x? Is hard, okay, because we are only given tangent theta as to x, but yet how to read or change it in terms of tangent theta. Okay lah, over here you can change tangent theta, which is to x, but here secant, it's quite difficult, especially there's the ln, right? So I think an easy way is change the boundary in terms of a theta like this. Okay, coming back, so when x is 0, theta is inverse tangent 2 times 0 is 0. So tangent 0, what is tangent theta as 0? Tangent theta 0, so meaning theta angle should be 0. Okay, 0, 0 radian. So hence our boundary there, we change in terms of a theta. So theta, the boundary that we have got is 0 to upper boundary is pi on 4. So for the theta, so this is again pi on 4. Or over here, we have to replace lower boundary as 0 and upper boundary as pi on 4. Okay, let's read the values there. For example, tangent pi on 4. Okay, as we are replacing the angle. Okay, help me. Secant. Okay, secant theta. Secant is actually 1 on cosine. Okay. So let's say we are to read secant upper boundary, secant 45-degree angle. Or another word, 1 over cosine pi on 4. Okay, refer back to our right angle triangle. It's easy. Here 1 square root 2 for the angle of pi on 4. So tangent by definition or cosine by definition is adjacent over hypotenuse. Okay, it's 1 over hypotenuse is square root 2. So secant there is 1 on cosine, which is square root 2. Alright. And then we are to read tangent pi on 4. Tangent 45-degree angle is 1, easy. And secant, we have got that, and tangent. So now let's replace it. So let's check the work. I have substitute. So you have to change the boundary in terms of a theta, m1. And then plug in upper boundary minus lower boundary. Make sure you show it, okay, before you get to your exact value numbers. And then simplify. So make sure you get this exact value and show your exact value number. But this is very simple. Okay, like for the example, maybe plug in and simplify your answer. Here we have a ln 1, which is 0. Alright, and cosine 0 is 1. So secant 0 is 1 on cosine 0, which is 1. So we get 1 for that secant value. So that's the detail of on the step-by-step work. This is how you should do. We know that under Mathematics 3, on the marking scheme, if M0, you did not show your work, automatic A0. So that is the long working that we do. And altogether here I give around 13 or 14 marks. 1, 2, 3, 4, starting with the trigo substitution, differentiation, and change into identity, and then solving the secant power 3 case, the 7 marks that we have had, you have to go back to your workbook page 243. Okay, there's a 7 marks there, or 6 mark. And then this is the answer, we quote the answer. And since that this is a definite integral, it's easier if you change the boundary as well. Make sure that you show all the working before you get to it. Okay, and then the upper boundary, substitute into the upper boundary of theta minus the lower boundary of the theta, and simplify your answer. You can carry maybe 13 marks altogether. We will do this for definite integral, but yet if this is indefinite integral without the boundary, you have to replace back your theta in terms of variable x, like in your example 1. Okay.